Good morning, YouTube. And here we go. Let's take a look at 2016 BC2. Let's see, at time t, the position of the particle moving in the xy plane is given by the parametric functions x of t, y of t, where x prime is given, and the graph of y is given, and it's made up of three line segments as shown in the figure above. At t equals 0, the position of the particle is at 5, 1. Can you find the position of the particle at t equals 3? Okay, so let's see. Well, y of 3. What's y of 3? That's easy. Look at the graph that they give you. I need x of 3 and y of 3, right? Y of 3 is the y value in this graph, right? Now look at this graph. Doesn't it go through the point 2, -1 and the point 4, 0? So that it has a slope of up 1 over 2, 1/2. So if y of 2 is -1 and y of 4 is 0, then isn't y of 3 -1/2? So I got y of 3 is -1/2. Let's start with that. Okay, so 2a. I've got y of 3. Let's put this somewhere. Y of 3 is -1/2 from the graph. Done. Okay. Now, what's x of 3? Well, remember that they gave you x prime is t squared plus sine of 3t squared. And they gave you that at t equals 0, x equals 5. So, what if we did an integral from 0 to 3 seconds, whatever the units are? They want that t equals 3, right? The integral of x prime from 0 to 3, isn't that x of 3 minus x of 0? And we know x of 0 is 5, so we can get x of 3. Aha, that's it. So let's take a look at that. So I'm going to say that the integral from 0 to 3 of x prime of t dt, is going to be x of 3 minus x of 0 by the fundamental theorem of calculus, right? So to get x of 3, don't we just add x of 0 to both sides, which is 5? So x of 3 is going to be 5. X of 0, let's add it to the left-hand side. 5 plus that integral from 0 to 3 of x prime dt. And let's find that on the calculator, okay? All right, so the calculator says, let's see, bring out the calculator. Oops, sorry, calculator, where are you? All right. So I need 5 plus the integral, let's see, math 9, of, what was it, t squared plus sine of t, right? So from 0 to 3 of t squared, now I can use alpha t here, but let's use x. X squared plus sine of wait a minute, hang on. Do you have the questions? I don't have the questions in front of me, sorry. Oh boy. Let me go back to the questions, sorry. The questions say 3t squared. T squared plus sine of 3t squared. So sorry. So plus sine of 3t squared. I'm using x instead. Alright, with respect to x. Whoops. And there it is, 14.377. That's it. I don't know why I told it to do it twice. 14.377. So we can go back to our notes and write 14.377 approximately to the nearest 3 decimal places, nearest thousandth place, right? Okay, that's pretty typical. Alright, so that's 2a. Done. So we have x of 3 is approximately 14.377, and y of 3 is -1/2. If you want to write it like in vector notation, we have the x component and the y component. That's an approximation for the x component. Okay, next part, part B. Find the slope of the line tangent to the path of the particle when t is 3. All right, so that's dy dx along the trajectory, right? Okay. At x equals 3, or t equals 3. So, what are we going to do? Let's see. Let's try. Let's see, 2b. Let's see. It's going to be dy dx is dy dt over dx dt. All right, now what's dy dt at t equals 3? Let's look at the graph. At t equals 3, didn't we say dy dt was a slope of that line from 2, -1 to 4, 0 isn't at 1/2? So we've got that. And then, don't forget that x prime dx dt is given as t squared plus sine of 3t squared. Just plug in 3. Okay. So I'm going to have, let's see, I'm going to have 1/2, the slope of that little line segment, over t squared when t is 3, that's going to be 9, plus sine of 3t squared when t is 3, that's going to be sine of 27. And let's figure out what that is on the calculator. All right, calculator, where are you? All right, let's just clear this out. So we 1/2. Let's see, how about alpha y equals 1? And then an alpha y equals 1 again. Can I do that? There I can. Of 1/2, or I could have just done 0.5, over 9 plus sine of 27. Don't forget, you better be in radian mode for this. I am. Okay, enter that. And it's 0.050 if you round off the 3 places, approximately. Okay, very nice. So I'm going to say 0.050. Alrighty. And just for fun, y prime of t for all t on the interval from 2 to 4, that line segment that we talked about, isn't that y of 4 minus y of 2, I don't know if you have to show this, but there you go, just to be complete, over 4 minus 2, which was 0 minus a -1 over 2, which is 1/2, just to show where the 1/2 came from, okay? Alright, part C. Part C says, find the speed of the particle at t equals 3. Now the speed of the particle is the magnitude of the velocity vector. Alright, so let's talk about the velocity vector and then find its length. To C, I want the velocity vector at t equals 3. That's going to be x prime at 3 and y prime at 3. Alright, but didn't we just figure out x prime of 3? And what, didn't we just figure out, yeah, x prime of 3 was 9 plus sine of 27? And y prime of 3 was 1/2? We figured out all of this stuff already, right? So that's your x prime and y prime at 3. Now what's the magnitude? The magnitude, the length of the velocity vector, the speed, that's what they wanted, right? Is the length of that vector, which isn't that going to be 9 plus sine of 27 quantity squared plus 1/2 squared, square rooted, the magnitude of the vector. And let's see what that is approximately on my calculator. Alright, so it's going to be the square root of the quantity, 9 plus sine 27, close the quantity, close the sine, close the quantity, square it, plus 1/2 squared is plus 1/4, right? And you get 9.969-ish. There are no units here, so don't worry about that. Alrighty. Alright, so we get approximately 9.969 units. I don't know, feet per second or something, whatever it is. Okay. Alrighty. Now, go back to part D. Find the total distance traveled by the particle from t equals 0 to t equals 2. In other words, arc length, right? So what do I want? I want, let's see, 2D. I want the arc length to be equal to the integral from 0 to 2 seconds, whatever the units of time are, of x prime of t squared plus y prime of t squared square rooted dt, which is sort of what we did for the magnitude of the velocity vector, right? The square root of x prime at 3 squared plus y prime at 3 squared. All right, but the problem is x prime of t is the same throughout, but y prime of t changes from 0 to 2. Look at the diagram. From 0 to 2, y prime, the y prime of t, that slope here, is down 2 over 1, is negative 2, isn't it? And the slope of this line segment, this is 0. So, let's write that up. So that's going to be, all right, so what does that mean? That means that L is the integral from 0 to 1 of x prime of t squared plus negative 2 squared. That's going to be 4. Square rooted dt plus the integral from 1 to 2 of x prime of t squared plus 0 squared square rooted, in other words, the absolute value. Okay. The absolute value of the integral of the absolute value of x prime of t. And so let's plug that into the calculator. Alrighty. Now, x prime, remember, was t squared plus sine of 3t squared, right? Okay, so let's go to the calculator. I'm curious. Let's graph this just for fun. Let's see what this looks like. Let's use x in function mode, so instead of t. So x squared plus sine of 3x squared. And I'm only interested in the region from 0 to 2. From 0 to 2. And let's see what that looks like. It looks like it's always positive. I don't see any negative part here, so I'm not going to worry about the absolute value part of it. Alrighty, so let's do it. Here we go. So let's go the second quit. I mean, I could do this on here, can I? That's interesting. Oh, let's just do it on this one. Alright, so it's going to be math 9 from 0 to 1 of the square root of, okay, here's the quantity, let's use x. X squared plus sine of 3x squared. Close the sign, close the quantity that we're squaring, plus 4, with respect to x instead of a t. Hi, I'm recording. Huh? I'm recording. Oh, sorry. Oops, what did I do? Oops, I didn't hit the x. There you go. Alright, so we get 1.174 out of that piece, right? Okay, now, let's do math 9 from 1 to 2 of just x, the square root of x prime of t squared, which is the absolute value of x prime of t, but there was a negative, so it's just x prime of t. So x squared plus the sine of 3x squared, close the sign, with respect to x instead of t, what the hey, and we get this. And then we just add these two amounts together. Take this plus this, and you get, what did I do? I did something wrong. Oh, I know what I did. Look what I did. That's why there wasn't an x in here. This is wrong. That's why I didn't get an x in here. I put it here by mistake. Get rid of that. Delete that. Okay, fix that. That's different. Okay, that's from 0 to 1. And then from 1 to 2, we still got this. So it's going to be this plus this is, to the three places, 4 point, let's say 350. So we get approximately 4.350. They don't give a units, but some kind of units of length, maybe feet or some such thing. Alrighty, that's it for 2016 BC2. I hope you found that helpful. That's the end of the Part 2A Calculator Active section of our AP exam for 2016. Alright, bye-bye YouTube.